Hello, guys. Well, today we're going to uh, find out how to solve this exercise here, number 4. So, if these are just Brownian motions, right? That is, each one has normal distribution with mean 0 and variance, in this case, 1 times sigma square. Uh, for this case, that would be something like a normal random variable with mean 0 and variance n sigma square. Then this sum has normal distribution with mean 0 and variance given by sigma square and all this stuff here. They hint us to use this formula, right? And well, we're going to see how this is true. All right. So first of all, let's take a look at the fact that it is very simple to see that W1 plus W2 plus W3 plus Wn is normally distributed. Why? Well, because what we have in here is just the linear combination of a bunch of normal random variables. So it is very easy to see that the distribution of the sum is just normal. Now, how to see that the expectation is actually 0? Well, the only thing we have to do is to use the linear property of the expectation operator and write just W1 plus the expectation of W2 plus central dots plus the expectation of Wn. This is just the sum of a bunch of zeros, and there we go. Now, to see that the variance is given by that formula there, the only thing we have to do is this. Well, one would be hopeful to see that this is true, right? However, we just cannot ensure that this thing is true because these two random variables are not independent and the variance is not a linear operator. So what we will do is that, well, we'll write W1 plus W2 in the form of just W1 plus W2 minus W1 plus W1. That is 2 times W1 plus W2 minus W1. So what we have in here is a couple of random variables which are independent because the Brownian motion has independent increments, right? So the only thing we have to do for that case is just the variance of W1 plus W2 is just given by the variance of 2 times W1 plus W2 minus W1. There we go. And what we have in here is just the variance of 2 times W1 plus the variance of W2 minus W1, which is just 2 square times the variance of W1 plus the variance of 1 square times this variance here, which is just sigma square, right? So what we have is just 2 square times sigma square plus 1 square sigma square, and there we go. Now, for the case of, for instance, W1 plus W2 plus W3, all we have to do is to take a look at the fact that we can just write this as 3 times W1 plus 2 times W2 minus W1 plus W3 minus W2. Because when we have just these 3 here and we subtract 2 from them, then we just keep the original W1. And then if we take from these 2 W2s and we take 1 from them, then we just are left with this guy here. And this W3 is just this W3 here. So when we take the variance of W1 plus W2 plus W3, what we have is just the variance of 3 times W1 plus 2 square the variance of this here plus 1 square the variance of W3 minus W2. And what we have there is just 3 times the variance of W1 plus 2 square the variance of W2 minus W1 plus 1 square the variance of W3 minus W2, right? So in general, what we have is that to write this is just the same as writing n times W1 plus n minus 1 times W2 minus W1 plus n minus 2 times W3 minus W2 plus and all the way up to Wn minus Wn minus 1, right? Why? Well, because of an analogous reason to the one we displayed right here. So if you take these n minus 1 W1s and you subtract them from this guy here, then you're left with just the original W1. And if you take these n2 W2s and you subtract them from these n minus 1 W2s, then what you have is just this one here, and so on and so forth up to this term here. So we can just take the variance of W1 plus all the way to Wn, and that equals just n squared. The variance of W1, which is just sigma squared, plus n minus 1 squared times the variance of W2 minus W1, plus n minus 2 squared times the variance of W3 minus W2, which is just this, and all the way up to 1 squared times the variance of Wn minus Wn minus 1, which is just this here. And now we can just factor this expression here, so that we are left with just n squared plus n minus 1 squared plus all the way up to 1 squared times sigma squared. And by just using the formula that was pointed out to us by the hint, right? We can just complete the exercise and say that this sum has a normal distribution with mean 0 and variance given by this.